Hey physics friends, Mr. Collier here, and today I have another conservation of energy problem. Here we have a skier on a 15-meter high ski slope. They push off at 4 meters per second and then they coast down the hill, and we want to find their speed at the bottom. So like many physics problems, this is about having a diagram and understanding the kind of concepts at play. So the height of the ski slope, that 15 meters, means that at the top of the slope, they've got some potential energy. But also, the fact that they push off at 4 meters per second means that they're also starting with kinetic energy. So they're going to start with potential energy and kinetic energy, and that's equal to their total energy. And one of the key concepts in this unit is that that total energy is going to be conserved. So that means that this kinetic and potential at the top is going to equal the total energy at the bottom. So now at the bottom of the hill, the skier will no longer have potential energy from height because they'll be at the bottom of the hill, so that'll just equal the kinetic energy at the bottom. So now we can arrange this a little bit more, and we can say that the mass times gravity times height at the top plus the 1/2 mv squared, the kinetic energy, and this v is the starting, will be equal to the 1/2 mv squared at the bottom. Okay, so now one thing we need to realize is that we could factor out mass from both of these, and it will cancel with this mass over here. So it doesn't really matter what the skier's mass is. So now we get g times h plus the original v squared will be equal to 1/2 times the final velocity squared. Now we can simply substitute those numbers. We know gravity is 9.8. We know the height of the hill is 15 meters. We know the starting speed is 4 meters per second. We're squaring that. And we know the velocity, or I'm sorry, we don't know the velocity at the bottom. That's what we're trying to solve for. So now if you plug in all your numbers, simplify, solve for the final velocity, you'll find that the skier is going 17.6 meters per second at the bottom of the hill. Energy is conserved, and that is how we solved the problem. Let me know if you have any questions.